Now, we are now going to get into the difference between an even function and an odd function. This is totally different from what we did in lesson 15, which was even degree and odd degree. So we're not talking about the degree. And this is the most common mistake. Students think a function is even when the degree is even. That's not the case at all. It has nothing to do with the degree. Same thing with odd, okay? So we're going to learn about what an even function is, and we're going to show two ways, one algebraically and one graphically, to determine if it's an even function or not. Okay, so here we go. We're going to start with even functions, focus on just even. It's going to take a little while to understand this, but it's not bad actually once we get it. Here's the definition. I don't want to, I have to talk about the definition, but you're not going to understand until we actually do it. A function is even if the equation f of x equals f of negative x is true for every number x. Now that means nothing to you. I know that. You're like, what is he talking about, right? We have to actually do it and you'll see how it works. But graphically, I think you'll understand it better. If a function is symmetrical to the y-axis, you guys know what symmetry is, right? Folds and lands on itself. If a graph is symmetrical to the y-axis, meaning you could fold on the y-axis and the graph lands right on itself, then we have an even function. Very simple. So that's the easiest way to tell. If you can graph it, easy. So we're going to start off with this. Consider this function here, f of x, x to the 10th plus 3. So here's x to the 10th plus 3. Again, I typed them in here just to save time, but only the first one's turned on. So see how it's, I have a black equal sign, a highlighted equal sign, x to the 10th plus 3. That's the one that we're going to graph right here. And again, I'm going to cheat. Here we go. Cheat, and you got to graph yours, right? So there it is. There's that's what x to the 10th plus 3 looks like. Okay? Now, a graph using the graphic calculator, we just did that. So you just sketch it the best you can. Is the graph symmetrical to the y-axis? Meaning if you folded along the y-axis, if you folded right along the y-axis, would the graph land on itself with no excess, nothing else left over? And as you could tell, yes, it would. It would, right? If you fold it along the y-axis, on your paper, if you did it right, okay, and you fold it, it lands right on itself. There's the same exact thing on the right side of the y-axis as there is on the left side of the y-axis. All right, so that is symmetrical to the y-axis, therefore, yes. So we already know it is an even function, but we're going to show how to do it algebraically without a graph. Okay, so evaluate f of negative x. We already know f of x. We want to see if f of negative x comes out to be the same thing. So f of x is this, x to the 10th plus 3. Let's do f of negative x. F of negative x basically just means take the function wherever you see x, put in a negative x. I know it's kind of weird, like why would you do that? That's just how you show that a function is even. So we're going to put a negative x in, and then we're going to raise to the 10th, and then add 3. Okay, so what happens when you take a negative x and you raise it to the 10th? Well, what happens when you take any number and raise it to the 10th? Negative times a negative is a positive, right? Times another negative is a negative. Times another negative is a positive. Times another negative is a negative. It alternates. So if you have like, for example, negative 2 squared, that's positive 4, right? But if you have negative 2 to the 3rd, it's going to be negative 8 because it's a negative times a negative times a negative. What if you do it to the 4th? Now it's going to be positive 16. 2 times 2, negative 2 times negative 2 times negative 2 times negative 2 is positive 16. See how it goes positive, negative, positive. To the 5th is going to be negative, to the 6th is going to be positive, to the 7th is going to be negative, to the 8th is going to be positive, 9th is going to be negative, to the 10th is going to be positive. It alternates. If you have an even degree, then the negative will go away. So that's how the degree matters. But basically an even degree, so now we have x to the 10th plus 3, my f of negative x is exactly the same as my f of x. See that? F of x is x to the 10th plus 3. F of negative x is x to the 10th plus 3. Plus I have symmetry over the y-axis. Based on your work in parts A to 3, f of x is f of x an even function? Explain your answer. So we're going to say yes, f of x is an even function. Because it is symmetrical. It is symmetrical to the y-axis and because f of x equals f of negative x. We showed that we did f of negative x, and you get the exact same thing as what you originally had, x to the 10th. Negative x to the 10th is the same as x to the 10th because of the even degree. All right? So let's do the next one. Now consider x squared minus x. X squared minus x. So we're going to turn off this one. And then we're going to turn on x to the squared minus x to the squared. X squared minus x. Let that graph. And bring it over. Now, I have an even degree. But is this graph symmetrical to the y-axis? It is not. If you look closely, there's more space over here than there is over here. There's more space over here. So this graph is not symmetrical to the y-axis. No. So just because I have an even degree does not mean I have an even function. Just because I have an even degree does not mean I have an even function. You have to do the graphing test or the negative x test. So let's do g of negative x. G of negative x equals, and you know it's not going to work, negative x squared minus negative x. Well, negative x squared is just x squared because a negative squared is a positive, right? So that's the same, but negative x is positive x. So take a look now. When I do g of negative x, I get x squared plus x, but I originally had x squared minus x. So when I do the negative x, it does change the function. Therefore, it is not an even function. So, based on your work in parts A to C, is g of x an even function? No. No, because g of x is not symmetrical to the y-axis. And also, g of x does not equal g of negative x. So that's another reason. So when you're doing this, you don't have to give both reasons. You can just give one or the other. But on our notes, I'm just giving you both. So you could pick graphically or algebraically. If they ask you to prove it graphically, it's just the graph, right? If they ask you to show algebraically, you have to do it this way. That's why we're doing it algebraically. Because on the exam, they might ask you, show algebraically whether it's an even or an odd function or not. So now what's an odd function? An odd function, a function is odd when f of negative x equals negative f of x. So that's kind of weird. We're going to have to do two things now. It's a little harder to show. And an odd function, it is symmetrical to the origin, which is the point 0, 0, symmetrical to that. So basically, if it flips over the origin, it's an odd function. Odd functions, another way to tell it, easy way to tell it, is by just, because it's a point reflection or a 180-degree rotation. It's the same thing. So what an easy way to do it is to just flip your paper upside down. If the graph looks exactly the same, it's an odd function. That's a nice, easy way to tell. All right, so we're going to mention that at the end. So let's do this graphically. X to the third minus x squared. Boom. Boom. We'll turn that on. I'll cheat again. There we go. Okay. So that right there, we have to decide if it is a, we have to decide if that is an odd function or not. All right. So we're going to, is it symmetrical to the origin? Well, if we flip our paper upside down, does it look exactly the same? Exactly the same? Is it exactly the same? It's close. Flip your paper upside down, it's close. But if you look carefully, there's more space here. That's a thicker space between the y-axis than there is here. I'll change colors. See that? There's not as much space here as there is here. It's further to the right. It's shifted to the right a little bit. So if you flip your paper upside down, it might look the same, but not exactly the same. So no, it is not symmetrical to the origin. Evaluate h of negative x and negative h of x. So we got to do this. We have to do two things here. We have to do h of negative x equals. So we're going to take our function and we're going to plug in negative x like we did earlier. So negative x to the third minus negative x squared. So this is going to be negative x to the third and then minus x squared. Because this negative squared becomes positive, but then we still have this minus here. So it's negative x squared. So this is what we get for h of negative x. Now let's see if we get the same thing for negative h of x. Negative h of x, how do you do that? Well, you just take h of x and you make it negative. You change the sign of everything, right? So we're going to go negative x to the third and then change the sign of this so it's positive x squared. All right, so do we get the exact same thing? Is this the same as this? Is that the same as that? And no, it's not. So based on this, is it an odd function? Well, we would say no because they don't match. So we'd say no because the graph, right, it's not, well, but we'll call it h of x. H of x is not symmetrical. Not symmetrical to the origin, meaning we flipped our paper upside down and it doesn't look exactly the same. It's close, but not exactly. And also the algebraic explanation is that h of negative x, I know this is going to take a little bit of time to get used to, does not equal negative h of x. I know that's going to, you're probably thinking, what is he talking about right now? Like, that's okay. Again, you're just getting some information to get you started in class tomorrow. We're going to have to go over this a little bit more. I know that. All right, let's do one more. I think maybe we'll get a little bit better here. And then consider x to the 11th. So we're going to do that real quick. This is the last one. So we're going to turn off our last one there. We're going to go to x to the 11th. Aren't you happy I had these typed in already? I saved you like 5 to 10 minutes of me typing in stuff. All right, here we go. Now, if you look at this one, look at that one now. Look closely, okay? And then try to sketch it the best you can. Then turn your paper upside down. This one is symmetrical to the origin because it's a 180-degree rotation. 180 rotation, and that's the same thing as flipping over the origin. It just flipped over the origin. 180-degree rotation is the same thing as flipping over the origin. You should know that from geometry. You probably don't remember, right? That's okay. Or maybe you do, all right? But either way, you got the same amount of space here as you do here. See that? Same amount of space there as you do there. The graph kind of goes like that, and it does the exact same thing on the other end, okay? So that is a reflection over the origin. So is it symmetrical to the origin? Yes. So we already know we have an odd function graphically, but we're going to do it algebraically just to show, because you may have to do it algebraically. That's why we're doing it. So let's do k of negative x. K of negative x is negative x to the 11th. Remember, a negative to an odd exponent is going to be negative, so that's negative x to the 11th. Negative x to the 11th is the same as negative x to the 11th. It's going to come out negative. If you have an odd exponent, it's going to come out negative. Okay, an even exponent gets you a positive because you're doing 2 of them, right? Or 4 of them, or 6 of them. Even amount gets you a positive. Now okay, so that's k of negative x. Now do negative k of x. Negative k of x is the negative of whatever k of x is. Well, k of x is x to the 11th, so it's negative x to the 11th. There it is. Boom, boom. They both come out to be the same, equal. So k of negative x equals negative k of x. So because you get negative x to the 11th for both. That's another reason why it's an odd function. So based on this, explain your answer. Yes, odd, because k of x is symmetrical to the origin, and also k of negative x is equal to negative k of x. All right, so note, not every function is either even or odd. In fact, most functions are neither. So again, it's not a matter of even or odd. You don't have to, a function doesn't have to be even. It can be neither even nor odd. Even is symmetrical to the y-axis. Odd is symmetrical to the origin with that 180-degree rotation, or you flip your paper upside down and see if it looks exactly the same. Most functions are neither. Think about everywhere these functions can be. Unless they're like perfect over the y-axis or perfect over the origin, they're not even and they're not odd. So you may get asked a question, is the following function even, odd, or neither? And that's the kind of stuff we're going to have to do. All right, so we'll practice this more in class tomorrow. See you then.